Assalamu alaikum, dear students. This is your fourth lecture. In the previous lecture, we studied about elements, compounds, mixtures, and types of mixtures. In today's lecture, we are going to study difference between compound and mixture, atomic number, and mass number. Difference between compound and mixture. Definition: pure form made up of two or more chemically mixed elements is compound, while mixtures are the impure substances made up of two or more physically mixed substances. Properties: for the particular type of compound, the properties are fixed and do not vary as the elements present in the compounds are fixed. The properties of the mixtures vary. They are not fixed as it depends on the type of substances and the quantity by which these are being mixed. Separation: the elements do not easily get separated, and if done, then it is by chemical methods. For mixture, the substances are easy to separate by different physical methods like filtration, chromatography, and evaporation, etc. Formula: compounds have a specific formula depending on the constituent present. Mixtures do not have a certain formula. Composition: compounds, they have generally homogeneous elements are present in fixed quantity, that is, their ratio is fixed. While mixture, they can be homogeneous or heterogeneous by nature. Substances present are not in fixed quantity, that is, their ratio varies. Melting point and boiling point: compounds once formed have fixed melting and boiling point. Mixture do not have a fixed melting or boiling point. Heat change: there is a heat change and energy is used or released during the formation of compounds as it is a chemical reaction. There is no heat change or involvement of energy is observed when mixtures are made. Examples: mixing of iron and sulfur. Now, this is a mixture and they can easily be separated with magnet. As iron and sulfur retain its properties, so iron will get attracted towards magnet and sulfur will be left behind. Example of compound: when iron and sulfur they are strongly heated, a compound iron sulfide is formed. They react with each other and they lose their properties, so the iron present within iron sulfide is no more attracted towards the magnet. Before going into the detail of atomic number and mass number, let us recall our previous knowledge about atom. Atom, they are building blocks of matter, and these atoms combine in numerous patterns and form different substances. All atoms except common form of hydrogen contains the subatomic or the fundamental particles, that is protons, electrons and neutrons. Protons carry a positive charge, electrons are negative in charge and neutrons have no charge, they are neutral. Protons and neutrons are present within the nucleus of an atom, while electrons revolve around the nucleus of an atom. The atomic mass or the mass of electron is almost negligible. Okay, atomic number. What is atomic number? As the name suggests, atomic number means the number assigned to a particular atom. On what base should an atom be assigned a number? Discovery of element, or on the basis of the quantity of element present in nature? But one promising way is on the basis of number of protons. It is because atom of every element has fixed number of protons, and that is unique to every element. All atoms of a particular element have the same number of protons, hence the same atomic number. Atoms of one element differ from those of other elements by the number of protons in their nuclei. So, atomic number can be defined as the number of protons in the nucleus of an atom or the number of electrons in an electrically neutral atom. Atomic number is represented by symbol Z. An atom is electrically neutral. It is because it contains the same number of electrons and the same number of protons. The number of neutrons is variable, resulting in isotopes, and isotopes are different forms of the same atom that vary only in the number of neutrons they possess. Why do we need an atomic number? The atomic number helps in defining the characteristics of the element, and that is, it is going to give you the information about the chemical reactivity of an atom. Examples. There are different elements with different atomic number present in the periodic table. Here are some of the examples. Hydrogen. The number of proton present in hydrogen is 1, so its atomic number is 1. Carbon contains 6 protons, so its atomic number is 6. Oxygen, its atomic number is 8 because it contains 8 protons. Sodium, its atomic number is 11. It contains 11 protons and 11 electrons. Atomic number. Now coming towards mass number, and mass number is represented by A. And this is also known as atomic mass, which is mass of an atom. As both protons and neutrons are present in the nucleus of an atom, they are together called as nucleons, and mass number is also known as nucleon number. The weight of an electron is almost negligible. Thus, the atomic mass of an atom is almost the same as its mass number. And how does it get determined? Imagine we have a bag which is made up of extremely thin material, so thin that it almost doesn't have any mass of its own. Now we fill the bag with the stuff. If this bag is placed on a weighing scale, can we say that the total mass of the bag will be the sum of the mass of all the objects inside it? Absolutely. Similarly, the mass of an atom can be calculated with the help of subatomic particles that are present within it. But we know that among all the subatomic particles, electrons are negligible. They are considered to be weightless. So we are left with protons and neutrons that are present in the nucleus, and these have mass. Mass number, it is the sum of the number of protons and the number of neutrons that are present within the nucleus of an atom. In order to find the number of neutrons of an atom, it is found by subtracting the number of protons from its mass number. This is the symbolic representation of atomic number and mass number. Mass number is represented by A, and it is present here, while atomic number is present here. For example, sodium, its mass number is 23, while its atomic number is 11. Keep it in mind that atomic number and mass number are always whole numbers because they are obtained by counting whole objects, that is protons, neutrons and electrons. Sum of the mass number and atomic number corresponds to the total number of subatomic particles present in the atom. The modern periodic table is arranged in such a way that all the elements have an increasing atomic number and subsequently increasing mass number. Examples: atomic number, mass number and subatomic particles of carbon. Carbon, whose atomic number is 6, it means the number of protons present within carbon are 6 and the number of electrons are also 6. Mass number, it can be found by adding protons with neutron, so the mass number of carbon is 12. It is represented like this. In order to find the number of neutrons that are present within carbon, it can be found by subtracting the atomic number from its mass number. You will get 6. So the total number of neutrons present within carbon atom are 6. Okay. Another example of oxygen. Atomic number of oxygen is 8. It means the number of protons present within oxygen are 8 and the number of electrons are also 8. In order to find the mass number, we are going to add the protons with neutrons, and that is the mass number of oxygen is 16. It can be represented by capital O with mass number and its atomic number. The number of neutrons In order to find that, we are going to subtract its atomic number from its mass number and we will get 8. So the number of neutrons present within oxygen atom are also 8. Thank you.